Welcome back. In this video, we're going to talk about using reduction formulas. So we should be familiar with integration by parts at this point in our class. And we may have noticed that sometimes we have repeated integration by parts where it's, when we're dealing with sine and cosine or e to the x or natural log of x, we get kind of a circular pattern where we end up having to repeat things over and over again. And because we've become so familiar with those patterns, we have these three common reduction formulas. So tangent raised to some nth power, natural log of x raised to an nth power, or a product of sine and cosine raised to nth powers, and that works as long as those nth powers are not the opposite of each other. All three of these reduction formulas are derived using integration by parts. So for this next example, we're going to look at tangent to the fifth power of x. So recall that reduction formula we had on the previous screen. We have the integral of tangent to the nth of x. So in this case, my n value is going to equal this 5. So my pattern for this is 1 over n minus 1 tangent to the n minus 1 of x minus the integral of tangent to the n minus 2 of x dx. So if we look at plugging in my 5 value, 3 n's, what we'll end up with is 1 over 5 minus 1, which is 4, tangent of x to the 5 minus 1 power, again 4, minus the integral of tangent to the 5 minus 2. 5 minus 2 is going to give us the third power of x dx. So again, we kind of have this circular pattern. You'll notice here we have an n equals 3. So we can apply that formula to just this second integral that's left in here. And instead of using n equals 5, we'll treat it as n equals 3. So the first part will remain. I have 1/4 tangent to the fourth of x minus. And so what will we get for this second piece? I'll get 1 over 3 minus 1 is 2. Tangent, 3 minus 1, tangent squared of x minus the integral of tangent, 3 minus 2 is to the first power of x dx. So now what I'm left with is 1/4 tangent to the fourth x minus 1/2 tangent squared of x plus, because those two minuses distribute, plus tangent x dx. So I still have an integral in here, and you may know the formula for the integral of tangent x, or you may not. And it can be easily derived or determined if you take tangent x and you think about some properties of trig functions. I'm going to treat tangent as a ratio of sine over cosine. So tangent is equal to sine x over cosine x dx. At this point, we can use a simple u substitution. I will let u be the value in the denominator. So if I let u equal cosine x, then the derivative of u with respect to x is negative sine x, or rather negative du equals sine x dx. So I have 1/4, I'm just going to rewrite all of this, tangent to the 4th of x minus 1/2 tangent squared of x. And subbing that in, sine x dx is going to give me minus the integral. That's going to become a du. I had a u in the denominator, and what was in the numerator became a 1. So integrating 1 over u, we know that would be the natural log of u. About 1/4 tangent to the 4th of x minus 1/2 tangent squared of x minus the natural log of u plus c. And so, of course, we would plug that u back in, which was cosine x, and my final answer is 1/4 tangent to the 4th x minus 1/2 tangent squared x minus the natural log of the absolute value of cosine x. And that's our final answer. So that's how we can use a reduction formula. It would be the same process for natural log raised to a power or some product of sine times cosine when they are both raised to powers, as long as those powers are opposite values, such as +2 and -2.